this is just extra credit, but for anybody watching the video, assuming I didn't make questions for the video, then the first word for attendance is Santana, since we were just talking about it. Well, a couple of us were. So Santana is the first word for attendance. Good morning. So Hunter is here in person. So since we're recording, I guess I should at least fill this empty space. Somebody's going to be watching this video. So I'm just going to talk about things that might help on this last week of classes. Something that I'm not going to say when everyone's here because I don't want to repeat myself. That's a tough one. Probably will just have to end up repeating myself. Yeah, I don't know. The last week of classes, everything's due today. Well, everything's past due, but, you know, it's too late to turn anything in after today other than the final exam, which will be next week, obviously. Let's see, final exam advice. I don't know. If you need more time to take it, again, make sure you contact me. If we can just meet online where I can see you and hear you and see your screen, then we can get rid of the time restraint. Last time, let's see, the last day to retake exam 3 is today, because after today you can meet me and we can meet and go over the exam so you can get the correct answers to help study for the final and to get your 5% boost or whatever percent boost it was, at least 5%, a 5% boost to your grade. Definitely studied the chapters, study guides, chapter 20, chapter 19, chapter 11 and 12. That's what we're going to cover today. As much as time will allow us, I almost guarantee you we won't be able to get through all 3. If you guys have things to take notes with, you might want to take notes. Well, you can always watch the video because I've already written the final recently. So as we're going through these, unless my memory fails me, I'll be able to say, you know, this will definitely not be on the exam. And this one most likely is. And I know I say that throughout the lectures, but this time I mean it because I mean, this time I'll be more accurate, more precise because I just wrote the final. So I have a better idea of what's on the exam and what's not. And it's all random. I picked random questions from the first 3 exams. Actually, the computer randomly chose them. And then I randomly chose 51 questions from the 3 study guides, so 17 apiece. So again, when you're studying, don't think this one's more important than the other. I better remember that, or there's no rhyme or reason for what's on there. Basically what I'm saying. So study it all, minus what I tell you today. That's definitely not going to be on the exam. Any questions about anything while we are recording? Do you have any other classes today? So this is your last class for the semester? Nice. Sorry it's at 8 a.m. I think I already asked you. I know I asked you, but did I ask you what you're doing over the summer? Yeah. Rings bells now. Good morning. Another thing for the final. So I'm not sure if I'm going to let people retake it or not. I don't know yet. But obviously, they would have to, even the retakes would have to be done before a week from today. So if you're banking on retakes, I would go ahead and do the exam early so I can make a decision early. And then you'll have time to retake it. Maybe I'll post some sort of announcement between now and Monday when I crunch some numbers. If I can get caught up grading all the old stuff, then we can have a better idea of where the grades stand. And if there's too many, if the class average is too low, then most likely people will be able to retake the exam. Final. Excuse me. Any questions? Well, we have an extra person here and there's 5 minutes left, so let's do a second word for attendance. And again, for you guys and for the person online, this is 100% extra credit. But if you're watching the video, this is just part of your video. The next word was Vivaldi, V-I-V-A-L-D-I, like the composer from Italy, since we talked about him too. Add this on here.
Can you spell that again?
V-I-V-A-L-D-I. And if you misspell it, that's okay. Morning. I was listening to him this morning, right after Cypress Hill. Morning. Good morning. Everybody's coming in at once. I'll just wait and do attendance all at once. Does anybody have a class after this, or am I the last one of the semester for everyone? Last one? Anybody? Yep. Last. How about you? You have any other classes after this on campus?
Not today, but I still have.
Oh, really?
Oh, yeah. I'm a double.
Oh, that's right. Yeah. Good morning. Morning. Excuse me. So I don't know how much time is left for those of you guys online, but as a reminder, today we're doing student evaluations. So anybody who's physically here will get double the attendance points, assuming you stay until the end. So for those of you too online, that is A-okay that you're online. But if you're on campus and want to get the double points, then come on over. Or if you're online right now, and you can drive here, of course that's not safe. I guess I wouldn't recommend that. But if for what I know, at least one third of you who are online right now will be late because you already told me. But you will get the double points because you'll be here to do the student evaluations. Anyway, we've got less than a minute left. I will do attendance for the last time this semester. Abigail is here physically. Kincaid, not here. Andrea, Thought I saw her, but she's not here. Mullins, not here. Lewis, not here. Cooper is online. Hunter is here. Both Meltons are here. Crowder, I think, was online. No, not that it matters. Reinhardt is here in red, so that's even more extra credit. Isabel's here. We already said that. Julia, not here. Talbert, not here. Kennedy is here. Morning. Julia is now here, physically. Hannah's here. Larissa is not here. Burford is online. Hughes, wait, did I get that right? Let me make sure. Yeah, Madeline is online. Hughes is not here. Galloway is here. Cook is here in red. Morgan is here. Tate is here. Burton is online, planning to be here. Kinder? No Kinder? Canterbury is here. Hobson is not here. Fisher is here. Well, it's 8:01, so we're officially past time. So I don't know what to do with late. I guess they can be late and then get double whatever points they would have gotten. Anyway, not that you guys need to worry about that. We are recording. Let's get started. As I mentioned earlier, you will get double your points today as long as you stay to the end and do the student evaluation. Somewhere around 8:40, 8:45, somebody will come in and relieve me, and he'll be, telling you how to fill this out, and I'll be away. That way you have a little bit of, you don't have to worry about me just being here. Let's see, Andrea, if you can, when you email me, can you remind me that you're on time? Because I said your name and then move forward, and I've already closed that out. All right, what are some other things? So the exam, today's just going to be covering the exam. It is exactly 100 questions. 49 of them are from the first 3 exams, and 51 of them are from the last chapters that we're going to try to cover today with the study guide. Or it's vice versa. Either way, it's darn near 50-50. And as I was mentioning earlier, there is no rhyme or reason, right? So when you're studying, don't think, all right, this is an important question. It'll probably be on there. Or this one's hard, so he'll probably do a hard one or easy, whatever. I chose them all randomly, right? So when you're studying, don't think you need to stick on one question because it's easy. That being said, once we're up and running and I start going through these study guides, I will try to tell you which ones will be on the exam or not. So if you have something to write with, you might want to use it, or you might want to just refer back to this video we are recording, because a lot of this that I'm telling you will be helpful, because I'll be able to say, oh, this definitely won't be on the exam, or this definitely will be on the exam. So any questions before we get started? All right. So the first word for attendance then will be the one highlighted in blue on the screen there. Whoop, there we go, that one right there. So if you're watching the video, that is one of the words for attendance. Anyway, this question will be on the exam. It won't be a mouse. I'll change the species, but let's talk about this really quickly. The common house mouse species Mus musculus, that's the species name, has the following taxonomic classification. And you can see here it starts with mus, so then we know, and then ends right here with eukarya. So I can tell by looking here that we're starting from the small and going to large. Does that make sense? Starting from genus. Because I know what you need to know for this question is a scientific name like we see here. The first part is the genus, the second part is the species. Thus, this must be the genus, right? So from there, now you can work what you should have memorized, which is domain, kingdom, phylum, class, order, family, genus, species, right? So with that being said, this question is asking what is the family. So I'm just going to show you how to work it out in your brain. So we have domain, kingdom, phylum, class, order, family. So that's the answer, would be Muridae. So obviously, if you're studying this, you don't want to memorize the fact that mouse is in the family Muridae, but that's how you'll figure it out. Does that make sense? All right. And for the exam, like I said, it'll definitely be a different species, and it could be in a different order. So instead of starting at mus or starting at genus, I might end it at genus, and it might be. It definitely is not going to be family. I'll ask you for something else. So domain, kingdom, phylum, class, order, not family, or maybe genus, right? So anything other than family, since we already did family. Any questions about that one? All right. Number 3, this one will not be on the exam because I told you I wasn't going to do like a history lesson. So the one about Aristotle versus Lamarck or whoever, that one will not be on there. I think this one might be on there. Natural selection can be defined as what? So the evolution of a population of organisms is correct, but it's not the most correct. So that's another good hint. When you're doing this exam, make sure you read all the options because natural selection is the evolution of a population of organisms. And the correct answer is this one. A process in which organisms with certain inherited traits are more likely to survive. Let's keep going here. And reproduce than individuals with other traits, right? So that is more correct than saying it's just the evolution because, genetic drift, genetic drift is a type of evolution. Artificial selection is a type of evolution. So that's why A is not the most correct answer, and D is. So any questions about that? All right. And keep in mind, too, that I'm going to change the wording, and obviously it'll be shuffled. So again, when you're studying this, don't memorize, oh, the answer to number 4 is D, right? Because this probably won't be number 4, and there won't be the A's, B's, C's, and D's will be shuffled. All right. Actually, before I keep going, does anybody have any specific questions? Like you've already done the study guides and you need help with some of them? All right, then I'm just going to go through these as quick as I can before we run out of time. Because again, my idea is to let you know what's on the exam and what's not. Natural selection. So this other version, this question might be on there too. Results in evolutionary adaptation. That is correct. It's not very rare, so that's incorrect. It does affect allelic frequencies, even though we don't really talk about it much for natural selection. And it doesn't prepare organisms for future changes, right? Because we can't predict the future. Natural selection results in evolutionary adaptations. It's all about the present, right here and now. Any questions about that one? All right, this question won't be on there. I didn't ask about where the evolutionary adaptation idea first came back to. I didn't ask any questions specifically about the beagle. So there's a question that mentions the beagle, but it's not about the beagle. So this question will not be on there. Yes, this question will be on there. This is the one that mentions the beagle, but it's not about it. But on his trip on the beagle, Darwin found what? He found, let's see, plants and animals living in temperate regions were more similar to each other. Good grief, this would be easier to read if I could do it like this. Regardless of the continent on which they were found. That's the correct answer, right? Actually, no, I'm sorry. Good grief. That's the incorrect answer. I'm trying to rush through this. This one's the correct answer. Let me start. Plants and animals living on a continent seemed more closely related to each other. Scroll on over there. Than to plants and animals living in similar regions on other continents. So the point being, it's all about geographic proximity, is what he found out, right? They're more closely related if they were more closely living next to each other, as opposed to living in similar temperaments or biomes. Number 9 will not be on there. I'm not going to ask you any questions about Charles Lyell. It's a geology question. On the origin of species, Darwin argued that mechanism of descent with modification was. I don't remember if this question's on there or not, but the answer is natural selection, right? You should just almost always associate Darwin with natural selection for this exam. Any questions so far? All right, which of the following is a component of the fossil record? If I remember correctly, this is not on there, but the answer would be bones of extinct whales, right? Because bones are fossils. Molecular sequences are useful, but they're not fossils. Similarities of forelimbs, blah, blah, blah. Those are useful, but that's homologies. That's not fossil records. And of course, the distribution of any kind of plant or animals is not fossils. All right. Definitely number 12 is not going to be down there. That was one of those things that was from your old textbook, and I told you I was not going to ask you any questions about that on the exam. This one really might be on there. You definitely should know what homology is. It is evidence of artificial selection. Any questions about that? the next word for attendance, speaking of which, is again up there, highlighted in blue. So that is the next word for attendance. All right. Which of the following are homologous? This question is on there. I changed up the wording, so we're not going to be talking about dogs and cats and butterflies and sparrows and mosquitoes and hummingbirds, but the concepts are the same. So remember, homologs are things that they have different functions, but they used to have the same function from a previous ancestor. So they're basically the same part, but on a different animal or a different, yeah, that's a good way of putting it. So for example, the forelimb of a dog and the hind limb of a cat are not homologs, because one's a forelimb, one's a hind limb, right? Completely different. But the correct answer for this is forelimb of a dog and forelimb of a cat, right? So they obviously have a common ancestor. They're both mammals. We're talking about the same part. So even though they're slightly different among them, they are homologous because they came from the same common ancestor. Speaking of which, the reason this is wrong is because they don't have a common ancestor, or at least the wings don't, right? Wings of a butterfly and wings of a sparrow, right? Insects got their wings in a completely different lineage than birds got their wings. And the same can be said for, again, mouths of a mosquito, beaks of a hummingbird. We're talking about insects versus birds again. So any questions about that? All right. The similarity of the embryos of fish, frogs, and birds and humans is evidence of, I don't remember if this question's on there or not, but the answer is common ancestry. And I don't think it is on there because I already had a question about common ancestry. And I know I said this was random, and I guess that was on accident a lie. It's mostly random. I was just going through questions, and if I came to another question, I did think to myself, did I just do a similar question? So I guess that's a hint. I tried not to have any kind of double questions. So you might have some that are like asking the same concept, but not many. Anyway, natural selection generally results in what? This question is on there. I'm almost positive. And as the population is adapted to its current environment, right? First of all, increased variation. Sometimes we know from the three different outcomes of natural selection, whether it be disruptive selection, directional selection, or stabilizing selection. Sometimes we do get increased genetic variation, like with disruptive selection. Sometimes we get less, which would be stabilizing selection, right? And again, nothing about the future. We can't tell the future, right? Natural selection has nothing to do with the future when you think about it that way. And of course, sometimes it could increase the population size, but other times it wouldn't. Any questions about that one? Yes. Oh, thank you. I don't know. Tell him, oh, he's on there. Good looking out, though. All right. That'll make it tougher for the video, but it is what it is. All right, back to it, and thank you for letting me know. Which of the following, did I say that? Yeah, which of the following is not a requirement of natural selection? I think this question is on there, and the answer is gene flow. Of course, gene flow won't be the correct answer when you get that on the exam. I'm going to pick another thing that's not a requirement of natural selection. The gene flow is a type of microevolution, if you remember. It is a type of evolution, but remember, natural selection is just one type of evolution. So another type of evolution is not going to be a requirement of natural selection. We do need differential reproductive success. We do need a relative overproduction of offspring. And obviously, you have to have genetic variation. So again, this question will be on there, but the correct answer will not be gene flow. I'm going to choose something else that you should recognize as not part of natural selection. And then same with these. The other three, they might be something else that is a requirement of natural selection other than those three. Any questions? All right, let me think. Just to be fair, since I didn't say them out loud, what were the first two, the words I gave so far? Can anybody tell me? Mouse and artificial. Okay, so for the first two words for that we've shown since we started with mouse and artificial, since I wasn't showing the screen and you couldn't get it. Anyway, which of the following statements is true? Yes, a version of this question will be on there. Natural selection works on variation already present in the population. That is the correct answer as written. But for the exam, I don't remember what I did, but I know I turned that one into a wrong one, like maybe saying natural selection does not work on variation, maybe something like that. And let's see, some of the wrong answers. Natural selection works on non-heritable traits. I can make that the correct answer by saying natural selection works on heritable traits. Individuals evolve through natural selection. I could change that. That is incorrect. I could change it to make it correct by saying populations evolve through natural selection, or individuals do not evolve through natural selection. And then finally, individual organisms evolve structures they need. I could change that to say individual organisms do not evolve the structures they need. So any questions about that one? All right, I'm trying to go quick because this is recorded and we're short on time and have a lot to cover. Which of the following is a population? Yes, there will be a version of this. Let's talk about the answers, why they're right, why they're wrong. The termites, and your version of this is going to look different. It won't be about termites, but the termites infesting your house, so far that's a population, along with the microorganisms living in the guts. Not anymore, it's not a population, that's a community now because we're dealing with more than one species. All the termites that have ever lived, we are dealing with one species, but they're not at the same place at the same time. Therefore, that's not a population. All the organisms living in your house, again, that's more than one species, so that would be a community. So finally, the correct answer is the termites infesting your house, right? One species, one place, same time. Any questions about that one? All right, before I go to the next question, speaking of running out of time, this is how I do exam reviews. So whatever I don't cover today, if you guys want to meet me individually anytime between now and when you take the final, so we can do this slower and cover other things, and let me know. I'll be glad to do this one-on-one. Which of the following can create new alleles? I don't remember if this one's on there, but the answer is simply mutation. There's not much else to say about that. Mutation is the only thing that can create new alleles. Now, natural selection can amplify those alleles, right? Like with the moth, a lot of people miss this question. The smoke didn't create that new allele, the black allele, right? It was just random. It was a mutation. And then it just so happened that mutation was beneficial. Therefore, because of the smoke, more moths had that allele. The collections of all alleles in a population at any one time make up the populations. I don't remember if it's on there. It's a really easy one, gene pool. Not much else to say about that, right? The total collection of alleles in a population, that's the gene pool. What frequency of, yes, there'll be some version of this, and it will be very basic math, just like this one. The frequency of one allele in a population is 0.7 with two alleles, right? So what is the frequency of the other? So if one of them is 0.7 and they all have to equal 0.1, then the answer is obviously 0.3. Does that make sense? We're saying frequency, and your mind, if it helps you, think of it as a percentage. If the frequency of the percentage of one allele is 70%, obviously the other percentage has to be 30 because it has to equal 100%. Does that make sense? Very simple math. You'll have that question on the exam. The numbers will be different, but the math will be that simple. Bring a calculator if you want, just in case, but they should be simple. This question, some version of that will be on there in the Hardy-Weinberg formula. What does P squared represent? And it represents the frequency of, let's see, PQ, 2PQ, yeah, frequency of the dominant allele. Excuse me, I'm sorry. When it's P squared plus 2PQ plus Q squared, so remember those are three different things, right? When we talk about three different things, we're obviously talking about genotypes, right? Homozygous dominant, heterozygous, homozygous recessive. So if it's P squared, it is there we go, frequency of homozygotes for one allele. And specifically, again, if it's P squared, it's dominant homozygotes, and if it's Q squared, it is recessive homozygotes. Any questions about that one? All right. Similar question, talking about this Hardy-Weinberg formula again, except now we're saying what does 2PQ represent, and those are their heterozygotes. Any questions about that one? All right. The origin of genetic variation that serves as the raw material, I already mentioned this one before. So again, I don't know if it was the one I mentioned earlier or this one, but one of them is probably going to be on the exam, and the answer is mutations. It's pretty simple. Mutation is the origin of the genetic variation. Any questions about that one? All right. Which of the following is a characteristic of a population at Hardy-Weinberg equilibrium? Skipping that one. I'm almost positive that one's not on the exam. But if it was, the answer is the population's not evolving. Genetic drift. I'm pretty sure this one's on the exam, and the answer is chance. Genetic drift is the result of chance. Not much else to say about that. Gene flow was one of the other ones we talked about. That was the result of immigration with an I and an M, right? Things coming in and leaving a population. Anyway, any questions about that one? Which of the following will prevent significant genetic drift? That one's not on there. After surviving a bottleneck, that one's not on there. I'm going to come back to this chapter because I think that's it for the questions on this chapter. But I'm going to keep it open just in case. Let's go to the next one, chapter 19. What is the population? We already talked about this. I don't remember, since I've already asked that question, if I'm just going to straight up ask it this way. But just in case, let's talk about it very quickly. A group of organisms that occupies the same general area at different times? Nope, not at different times. A group of individuals of a single species? Yes, that occupies the same general area at the same time? That's the answer. B is the right answer. But again, I think I gave the other version and just that one as opposed to this one too, right? So the other one is giving you examples. This one's asking for the definition. So the next word for attendance will be that one in blue. And now that the screen is showing, those of you online can see it. Anyway, I will definitely ask questions about type 1, type 2, type 3 survivorship. So which of these characteristics type 1 survivorship? Low survivorship for the very young? Nope. Just think about type 1 is us. Most individuals survive to older age intervals. That's the best answer. Survivorship is constant. Nope, that's type 2. Survivorship is high for the few individuals that survive to a certain age. No, that's also type 1. So the answer is the answer is most individuals survive to older age intervals. Meaning, like think for humans. Yes, we do have deaths at birth, right? Babies do die, and people do die between, being born and becoming an old person. But generally speaking, when you think of humans and you think of death, you probably think of old people, right? That's the type 1 thing. Type 1 survivorship curves are typical species that exhibit. I don't remember which ones I asked. And again, there are questions about this, so let's just talk about it very quickly. Intermediate? No. If it's anything about intermediate, that would be a type 2. Few offspring and good parental care? Yes. Type 1, again, would be humans, right? Well, there's one example. So humans have relatively few offspring, and we take care of them, right? They're in our house for at least for 18 years. Which best describes type 2? So type 2 is it's just right down in the middle. So I'm going to look for an answer that looks like that. Yeah, survivorship is constant over the lifespan. It's not like a high death rate for the very young or a high death rate for the very old. Survivorship is constant. Any questions about that? All right, which of these best describes type 3 survivorship? So again, this is opposite of type 1. High survivorship for the very young? No, that's type 1. Most individuals survive to older age intervals? That's type 1. Survivorship is constant? That's type 2. Survivorship is high for the few individuals that survive to a certain age. That's the correct answer. So just like an oak tree drops thousands of acorns, each one of those is an offspring. Most of those acorns don't make it, but the few that do sprout up to and become a sapling will usually live to be a lot older than we are. Anyway, opportunistic species, I don't remember if this is on there or not. It might be or not, but the answer is they're not long-lived. They do have a large number of offspring, so that's the correct answer. That's a good point for me to remind you. This is one of those questions where if it's on there, I think I changed the right answer and the wrong answer. So for example, like very long living, I could change that to be the correct answer by saying very short living. Having a large number of offspring, which is the correct answer, I can make that incorrect by saying having a small number of offspring. Reach sexual maturity slowly, I can make that correct by saying quickly. Exhibit a type 1 survivorship curve, I could change that, make it correct by saying exhibit a type 3 survivorship curve. They're good? All right, so again, don't study these verbatim. They will be changed up. Species that exhibit an equilibrial life history. So remember, equilibrial is sort of like the opposite of opportunistic. They do have long lives, so that is the correct answer. And again, I could change it to say, make type 3 type 1, and then that would be the correct answer. Again, change type 2 to say type 1, that would be the correct answer. Have a small number of offspring, that would make that the correct answer. Any questions about that? Okay, this question is definitely on the exam. It is going to be simple math like this, but the numbers won't be 550. I don't remember what they are, but they're not 550. But the basic math is the same, and it won't be oak trees. But anyway, there are 500 oak trees in a forest covering 50 square kilometers. The population density is what? So, all right, if there's 50 square kilometers and there's 500 oak trees, I just have to ask myself 50 times what gives us 500, right? The answer is 50 times 10. So if there's 10 trees for every square kilometer, and there's 50 square kilometers, again, 10 times 50 gives us 500, so that is the correct answer. Everybody good there? And again, I'm only flying through this. If we had all the time in the world, I would actually stop and ask you to guess, and we could have fun with it. But I'm just flying through it because I want to get you as many answers as I can. And then the ideal unlimited environment, a population's growth follows what? And this, I think this question's on there, and the answer is exponential. Ideal unlimited, right? The population is just exploding. So the answer is exponential. And there's not much I can do to change the options. It's just exponential is the correct answer. On a related note, I think this question is on there. In an ideal unlimited environment, so again, we're still talking about exponential here, what shape does the population's growth curve most closely resemble? And the answer is J. It's a J shape. At least that's how they describe it, because remember, it goes kind of curves up at a steep acceleration. Any questions about that? All right. If a population's growth rate decreases as the population size approaches carrying capacity, the population's growth rate follows what? Logistic. It follows the logistic model. Not much else to say about that. That's just the correct answer, and I do think that question is on there, at least some version of it. Any questions about that one? All right. So again, similar question, but now we're talking about logistic growth pattern instead of exponential. So what shape does that graph have? And it's S-shaped. If it's logistic, it's S-shaped because it starts off going up, but remember, then it evens out when it hits carrying capacity. Speaking of carrying capacity, again, I think this question is on there. What is the maximum population size that a particular habitat can support? And the answer is carrying capacity. Once again, that's pretty straightforward. There's not much else I can say about that. That is just the correct answer. I can't reword it to make it correct or reword any of the other ones to make them correct. Any questions? All right. According to the logistic growth model, what happens to a population size when the size of the population reaches carrying capacity? Pay attention to this one. This one is on there, and I could see how someone would get this wrong. I could see how somebody would be thinking the right thing but then answer the wrong question or answer it incorrectly. The answer is the growth rate is 0. So don't be confused. We're not talking about as the population as it's getting close to carrying capacity. We're saying when it reaches carrying capacity. Once it's there at carrying capacity, the growth rate is 0. So don't let that confuse you. The correct answer is not the growth rate decreases. Because if you were to slightly change the wording of that question, then you could say the growth rate decreases as it gets closer. But again, once it gets to carrying capacity, at least according to the model, the growth rate is 0. Any questions about that? The next word for attendance, again, highlighted in blue. I think this question's on there, some version of it. Competition among individuals of the same species would be intraspecific competition. Don't let that confuse you with interspecific, because that would be between different species. So if it's a lion fighting with another lion over a dead zebra, that's intraspecific. If it's a lion fighting off hyenas for the same dead zebra, that would be interspecific. Anyway, any questions about that? All right, which of the following factors operates about? Yes, there will be a question about density-dependent manner and density-independent. So if it's density-dependent manner, that means its deadliness is dependent on how, what the population density is. So blizzards don't matter. You could argue in a small way that they do, but for the most part, a blizzard's going to kill everything that can't live in the snow, right? Same with a volcanic eruption. I don't care if there's 7 people at the bottom of the mountain or 700. They're all going to die once they get covered in lava, right? Food supply. There you go. There's the correct answer. And of course, when I reword it, there'll be something else. It won't be food supply, but it'll be something that is in a density-dependent manner where it matters how many individuals are in an area. So obviously, again, 7 people can live a lot longer on X amount of food than 700 people on the same amount of food, right? So the population density does matter. And again, flood doesn't matter. A flood's going to kill everything that can't swim, regardless of how many of them are in a square mile. Any questions about that one? 17's not on there. An unexpected freeze that kills a population of chipmunks is an example of, so again, we just talked about this. It's a different question worded in a different way, or same question worded in a different way. So some version of this may be on here, but if it kills everything, again, unexpected freeze, that would be density independent, right? It doesn't matter how many chipmunks are on WVSU's campus, for example. If it gets too cold for a chipmunk to survive, they're all going to die, whether there's 5 of them on our campus or 500. Any questions about that? All right, and again, for the exam, it wouldn't be a chipmunk. If I'll reword the question, so it wouldn't be chipmunks that die, and it wouldn't be an unexpected freeze, but it would be something else that's density independent. Endangered Species Act, no questions about that. No questions about the woodpecker. That one's too long, so I decided not to put it on there because you only have 100 minutes to answer 100 questions, so I didn't want you spending a lot of time reading. Non-native species, I think this is the end of where I got with that chapter, so just in case, I'm going to skip to the next one. If we have time, we'll come back. But I think those are all the questions from that chapter on the exam. Present species loss, I told you wouldn't need to know those numbers. Here we go. You definitely need to know this. This will be on there. The single greatest threat to biodiversity comes from habitat destruction and fragmentation. And when we talked about that, remember, the other options, you could think of it, kind of cause it, right? Invasive species cause habitat destruction. Overexploitation cause habitat destruction. Pollution cause habitat destruction, right? So all those other things cause habitat destruction and fragmentation. So hopefully that helps you remember it. Any questions about that one? All right. Several years ago, once again, that one's too long, so I didn't put it on the exam because I don't want you to waste your time reading. It's a rare thing to hear someone in education say, don't want you to waste your time reading. Anyway, mutualism, yes. I think there is a question where I give you some examples, like I said I would during the lecture, and say, which one of these is mutualism? But it wouldn't be like this. So the correct answer here is the relationship between corals and unicellular algae, but this was written by the producer or the textbook, people who wrote your old textbook, and they just expected you to know that because I gave you that as an example during the lecture. But like I told you, I'm not going to test you on examples. So when you get this question, it's going to describe the relationship. Does that make sense? This question is assuming you remembered the examples I told you, which I don't want you to do. When you get the question, I'm going to describe the relationship between these species and like, oh yeah, that's mutualism because they're both helping each other out. Any questions about that? All right, populations of 2 coexisting species, both tertiary consumers in a community. What relationship may exist between these 2 organisms? I'm pretty sure I have a version of this question on the exam, and they are competition. So it doesn't matter that they're tertiary consumers. What matters is that they're both tertiary consumers, right? They could be both producers or both primary consumers or both secondary consumers. The point is they're at the same level on the food web, therefore they're in competition with each other. Does that make sense? Because for the example I give won't be tertiary consumers, or it might be, I don't remember if I changed it or not. So the point is, don't focus on that tertiary part, focus on the both part. They're both part of the same level, therefore they're competing. Any questions about that? All right. As a result of a severe disturbance, a community will be, I don't remember if this question's on there, but they will undergo secession, right? So if you wipe out a severe disturbance, it's saying we wiped out a lot of the living things, if not all of them. So what's going to happen? Things are going to start coming back in a particular order, right? A redwood's not going to show up on a brand new piece of rock, right? First is going to be moss, and then you're going to get ferns and so on and so forth. You're going to start small and get big. Anyway, any questions about that side? Questions about the question. All right, organisms that consume producers. I'm pretty sure that one's not on there because it's so easy, and I like some easy questions, but not that easy. But if it consumes producers, it is a primary consumer, right? It's an herbivore if it's consuming producers, but another way of saying that is it's a primary consumer. Any questions about that? All right, in the food chain, this question is on there. The animals are different, but the concepts are the same. In this food chain, grass, antelope, human, lion, the antelope is eating the grass, so that makes it an herbivore or a primary consumer. What are the options here? That's not right. It is an herbivore, but it's not a secondary consumer. It's not a producer. You can't be a producer and a primary consumer You'd be eating yourself. Herbivore and a primary consumer. That is the correct answer. But remember, I'm going to use different animals, and I might not ask about the herbivore. I might ask about the secondary consumer or the tertiary consumer, or maybe I'll even ask about the producer. So when you're studying that, first of all, definitely don't memorize grass, antelope, human, lion. Just understand the food chain. Any questions about that side? Whew. All right, the food chain, grass, antelope, human, same one. The human, in this case, is the secondary consumer, right? Antelope is the primary consumer because it eats the grass. The human is the secondary consumer because it eats the antelope. Any questions about that? All right, small fish that eat zooplankton. We didn't really talk much about aquatic ecosystems, so that question won't be on there. Which of these converts organic matter to inorganic by breaking down dead organisms? No, that one's not on there because I didn't talk too much about the difference between detritivores and decomposers and scavengers, so I don't expect you guys to memorize the subtle differences between two of them. This one I did ask though. Most decomposers are what? And the answer is fungi and prokaryotes. And the way they wrote this question is kind of tricky because prokaryotes, as far as we're concerned, is basically the same thing as bacteria. So they did that to be tricky. I think I included the same nomenclature, not to be tricky, just to be lazy, so I could copy and paste it. Anyway, any questions about this slide? Okay. This one, I think some version of this question I think is on there. Bears eat berries. Bears also eat humans and large fish. Large fish eat smaller fish and insects. Humans eat bears. They also eat large fish and berries. Certain plants eat insects, right? So it's a big, complicated web. It's not a food chain, but a food web. Any questions about that? Pretty simple. Because the things we're talking about here, right there, that's a food chain. It even says food chain, right? When it's just step, food chain. It's all complicated. It's a web. Herbivory, that's probably not going to be on the exam. No, it's definitely not. The answer is plus minus. Yep, this one's on there. Some version of this. In order to assess the species diversity of a community, you would need to know the number of different species, right? So, 4 pine trees, 5 oak trees, 6 maple trees, whatever, right? Pine, oak, whatever. But you'd also need to know the number of different species, as well as what? And the answer is the fraction of, there we go, the relative abundance of the different species. So again, there's different ways of looking at biodiversity. Right now, it's easy. We all have humans in here. But if we brought in 5 cats and 2 dogs and asked, what is the species diversity in this room? You could say 3, right? Human, dog, cat. But then if you're talking about relative abundance, you'd be like, well, there's a lot more humans, and then there's fewer cats or dogs and even fewer cats. That's relative abundance. 16, I didn't ask that question just because it was a little bit too long. Yep, this question's on there, a different version of it. I'm not going to ask you about lakes, but anyway, 2 lakes have the same number of species. This goes along with what we were talking about earlier about species richness versus relative abundance. Most of the fish in Lake 1 are a single species with a few individuals for the remaining species. Lake 2, on the other hand, has about equal number of each species. Which lake has the higher species diversity? And the answer is Lake 2. They all have the same number of species, but they're more even in Lake 2, right? Lake 1 is like mostly this one species and a few of everything else. So that's what makes Lake 2 more diverse. Any questions about that one? We're running out of time. Let's do this for the next attendance word. The one covered in blue there. Let's scroll it up for you guys in the back. Everybody can see that? All right. I think this question is on there, some version of this. What is one way in which energy flow is different from chemical cycling? Energy flow is unidirectional. That is true, right? Starts at the bottom of the trophic levels, works its way up, so to speak. Chemical elements can be recycled. So far that is the most correct answer. Energy can enter but not leave an ecosystem. That's completely false. All energy does leave as heat eventually, even on Earth. Earth is putting off heat. Energy flows from lower to higher trophic levels, true. Chemical cycle from higher to lower trophic levels. That's only partially true. Yeah, it goes from higher to lower, but then back up from lower to higher, hence the name cycle, right? It cycles. So that second part is what makes that incorrect. Energy can both enter and leave an ecosystem. True. Chemical elements always remain within a single ecosystem. That's not true, right? Think about the Canal State Forest. You're in a forest ecosystem. There's leaves. They fall down. As soon as they land in the stream, it is now something that went from one ecosystem to the other, right? So chemical elements do go from one ecosystem to the other. Anyway, yep, this is a question. I said there was very few numbers I wanted you to know. This is one of them. Approximately what percentage of the visible light that reaches Earth's producers is converted to chemical energy? And the answer is 1. And just for your own knowledge, not for the exam, but remember, not all the light that hits Earth even gets absorbed by the plants. A lot of it is reflected and scattered. But yes, 1% of that is converted. Any questions about that? All right. I might have asked this. I don't remember. Biomass is the total amount of blank in an ecosystem. It's just living stuff, right? Is the way I like to put it. So living organic material is the correct answer. Yeah. Living organic material in an ecosystem. That's pretty simple. Any questions about that? So the biomass of this room would be if we all weighed ourselves and it somehow also got all the mold out of the air and all the bacteria on the, if we could somehow weigh it all, that would be the biomass. I think this question is on there too. The rate at which an ecosystem's producer converts solar energy to chemical energy stored in the biomass is called primary productivity. It's 8:41. I'm going to see if I can text the person who's coming. Sorry, I just want to make sure he gets here. Where is he at? Pencils. Okay. Anyway, yep, I talked about that. Yep, this is another one of those questions where I said you would need to know the numbers. On average, what percentage of the energy in one trophic level becomes incorporated to the next? So as you go up the step, the answer is 10. Only 10% makes it from one trophic level to the next. So if you have, I don't know, 100 calories worth of producers, then there's only going to be 10 calories worth of herbivores. And then there's only going to be 1 calorie worth of secondary consumers, so on and so forth. Every step is it's only 10%. Any questions about that? All right, what type of ecosystem? No, I'm definitely not going to ask you that one. Not going to ask you that one. I may have asked about this one. Besides the atmospheric abiotic reservoir of carbon dioxide include? No, I definitely wouldn't ask you that because I said you just need to know about the atmospheric abiotic reservoir. All right, let's go back to chapter 11 since he's not here. I'm pretty sure we've covered all the questions that are on the exam, but just in case, since we have time, since we're still waiting on the person to give those out, let's keep moving forward. Also, speaking of which, I don't know why I haven't done this. This has been that kind of semester. I should plan ahead for things not working. If he does not show up, keep an eye on your emails. We are done. It's the last day of the class. But if he does not show up, then I'm going to figure out something to do. Maybe I'll keep that in his... Oh, there he is. I was just coming up with a plan B. No.
I just texted him, said, are you ready?
Well,
That's really all your fault.
yep. All right, so that's it. The last word for attendance is right there in blue. And you guys, thank you. Good luck on the finals. Let me know if you need my help. We are done for this semester, but I'm definitely still here to help you. It's all yours.
Was there two?
They're 2 different sections. If you're section 1, your Monday lab. If you're section 2, your Wednesday lab. And to be honest, it doesn't matter. As long as you're not feeling too out, it's all the same.
So they should try to stick it in the right folder then. Doesn't matter.
That probably should matter.
Write a 1 and a 2.
In a
Section, you know what section you're in?
I know to say it on that. Yeah. So anyway, yeah. Section 1's right there, section 2 right here. And again, it doesn't matter too much, but if you get it out of the section 2 folder, put it in the section 2 folder. If you get it out of the section 1 folder, put it in the section 1 folder. Right? Doesn't
Yeah,
matter.
but they're all the same. So really, the only thing that matters is where they go in the end, right?
Oh yeah. Do you have a dry erase?
No.
I'll go grab you one.
All right.
And then I'll come back and take care of this.
Okay.
Can I use your key?